Hello everyone, welcome to today's lecture. So in today's class, we will study matrices and we will cover NCERT section 3.4.5, 3.4.6, NCERT examples 12 to 19. So what is matrix? A matrix is a rectangular array of numbers arranged in rows and columns. It is often used to represent data or solve system of equations, right? Matrices are denoted by capital letters A, B, C, right, and are enclosed in brackets. Okay. So this slides basically introduces the basic concepts of matrices, their dimensions, and fundamental operations like addition and multiplication. It sets the foundation for understanding how matrices are used in mathematical computations and real world applications, right? So let us see the images, text, and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the content immediately. Please note that parts of the content may have been generated using generative AI, which is experimental. So let us start now. So in today's class, we will study NCERT section 3.4.5, multiplication of matrices. Section 3.4.6, properties of multiplication of matrices. After that, we will study NCERT examples 12 to 19. Okay. So these examples will illustrate how to apply properties of matrix multiplication in practical scenarios, right? So let us see. So today we are going to explore the concept of matrix multiplication, right? NCERT section 3.4.5. The first thing to understand is that the product of two matrices A and B is only defined when the number of columns in matrix A matches to the number of rows in matrix B. Clear? This is crucial condition for matrix multiplication to be possible, right? Now let's delve into the condition for matrix multiplication. So if matrix A is m by n matrix and matrix B is n by p matrix, then the product AB will result in an m by p matrix. Okay. This means that the resulting matrix will have the same number of rows as A and same number of columns as B. Okay. So A and B is only defined. The in the product of two matrices A and B is only defined when the number of columns of A matches with the number of rows of matrix B, right? So A m into n is equal to A n into P. Here you can see that column of A is equal to row of B, which is n. So let's see the method to get the element Cik in the ith row and kth column of C. We multiply each element of the ith row of A by the corresponding element of the kth row of B, right? And then sum these products. So this process is repeated for each element in the resulting matrix. Okay. Right. So Cik will be equal to the sum of Aij times Bjk, right? Aij times Bjk, right? So Cik is basically equal to Ai1 into B1k plus Ai2 into B2k till Ain into Bnk, right? Which is equal to summation of j is equal to 1 to n Aij into Bjk, right? Summation of j is equal to 1 to n Aij into Bjk. Okay. Okay, let's move to the next part. NCERT section 3.4.5, example 12. Okay. So in this example, we are going to find the product of two matrices A and B. Matrix A is 2 into 2 matrix represented as 6, 9, 2, 3, and matrix B is again like a 2 into 3 matrix basically represented by 2, 6, 0, 7, 9, 8. Now remember, when multiplying matrices, the number of columns in the first matrix must match the number of rows in the second matrix, right? Here A has 2 columns and B has 2 rows, so we can multiply them, right? Also, we will calculate the resulting matrix AB step by step, focusing on how each element is derived from the rows of A and columns of B. Okay. So you have some times to solve or think about this question. After that, we will discuss the solution part, right? Okay. So hope you all have attempted the given question. Let us see how can we solve this, right? Now we will find the product of two matrices A and B. Matrix A is 2 into 2 matrix and matrix B is 2 into 3 matrix, right? So let's now see how can we multiply these matrices together. Since order of A is 2 into 2 and order of B is 2 into 3, here number of columns in A, which is 2, is equal to number of rows in B, which is equal to 2, right? Number of columns in A, which is 2, is basically equal to number of rows in B, which is equal to 2. So AB is defined and of order 2 into 3, right? This is because the resulting matrix takes the number of rows from the first matrix and the number of columns from the second matrix. Okay. Let AB is equal to, let AB as matrix C. So matrix C will be a 2 into 3 matrix, which can represent in general form as C is equal to C11, C12, C13, C21, C22, C23, right? Each element Cij in matrix C is calculated by taking the dot product of the ith row of matrix A and jth column of matrix B, right? Now we will calculate each entry of matrix C step by step. So we will start with the first row and move across each column, then proceed to the second row. So to find C11, we take the first row of matrix A and first column of matrix B. So we calculate C11 as 6 into 2 plus 9 into 7, which is equal to 12 plus 63, right, which is equal to 75. Now calculate C12, row 1 of A into row column 2 of B, which is equal to C12, right, which will be equal to 6 into 6 plus 9 into 9, which will be equal to 36 plus 81, right, which will be equal to 117. Now C13 will be 6 into 0 plus 9 into 8, which is equal to 0 plus 72, which is equal to 72. Similarly, C21 will be equal to 4 plus 21, which is equal to 25. C22 will be equal to 2 into 6 plus 3 into 9, which is equal to 12 plus 27, right, which is equal to 39. So C23 will be equal to 2 into 0 plus 3 into 8, which is equal to 0 plus 24, right, which will be equal to 24. Therefore, we can say that AB matrix is basically equal to 75, 117, 72, 25, 39, 24. Okay. Matrix AB is basically equal to 75, 117, 72, 25, 39, 24. Okay. Right. So hope it's clear to all. Let's move to the next part. Now today we are going to explore important properties of matrix multiplication. It's crucial to understand that matrix multiplication is not commutative, right? This means that even if the product of two matrices A and B is defined as AB and the reverse product BA might not be defined, or if it is defined, it doesn't necessarily equal AB, right? So this is a key distinction from regular multiplication of numbers where the order doesn't matter. Clear? That is, if AB if AB is defined, BA may or may not be defined, or if it is defined, then it is not necessary that AB is equal to BA. Clear? Now, many students assume that if you can multiply two matrices in one order, you can do so in the reverse order with the same result, right? However, as we have just discussed, AB does not always equal to BA, right? This is an important concept to grasp as it can affect how much how we approach problems involving matrices, right? You can remember that the order of the matrix multiplication matters significantly in matrices. Okay. So we have NCERT section 3.4.3 example 13. Okay. So in this example, we are going to explore the multiplication of two matrices A and B. Matrix A is 2 into 3 matrix, which means it has 2 rows and 3 columns, and it is represented as A is equal to 1 minus 2 3 minus 4 2 5. Matrix B is 3 into 2 matrix, meaning it has 3 rows and 2 columns, and is represented as B is equal to 2 3 4 5 2 1. So our task is to find the product of these matrices A, B, and BA, and demonstrate that matrix multiplication is not commutative, right? Meaning AB does not equal to BA. Clear? Now let's start by recalling the rules for matrix multiplication. So the number of columns in the first matrix must be equal to the number of rows of second matrix, right? This will guide us in calculating the product. Okay. So again, you have some time to solve or think about this question. After that, we will discuss the solution part. So you can try to solve the given question. After that, we will discuss the solution part. Okay. Okay. So hope you all have attempted the given question. Let us see how can we solve this, right? So we'll see how multiplying matrices can lead to different results depending on the order of the multiplication. Okay. Since A is 2 into 3, matrix A is 2 by 3 matrix, which means that it has 2 rows and 3 columns, right? Matrix B on the other hand is 3 by 2 matrix with 3 rows and 2 columns, right? This is crucial for determining if the matrices can be multiplied. Okay. So for matrix multiplication to be possible, the number of columns of the first matrix must be equal to the number of rows in the second matrix, right? Here both conditions are satisfied as matrix A has 3 columns and matrix B has 3 rows. Okay. Since the matrix multiplication is defined, the resulting matrix AB will have dimensions based on the outer dimensions of the matrices being multiplied, right? Therefore, AB will be 2 by 2 matrix, right? AB will be 2 by 2 matrix. So we represent the product AB as matrix C, which is a 2 by 2 matrix. So this is general form of a 2 by 2 matrix, right? Where each element Cij is calculated by taking the dot product of the ith row of A and jth column of B, right? That is multiplication product actually of ith row of A and jth column of B. Okay. Now let's perform the multiplication. So we multiply matrix A, which is 1 minus 2 3 4 minus 2 5, by matrix B, which is 2 3 4 5 2 1, right? So we'll calculate each element of the resulting matrix by taking the dot product of the corresponding rows and columns. Okay. So it will be 1 into 2 plus minus 2 into 4 plus 3 into 2, 1 into 3 plus minus 2 into 5 plus 3 into 1. Next is minus 4 into 2 plus 2 into 4 plus 5 into 2. Next is minus 4 into 3 plus 2 into 5 plus 5 into 1, right? Which is equal to 0, minus 4, 10, 3. 0, minus 4, 10, 3. Okay. Now let's consider the multiplication of B and A. Matrix B is 3 by 2 matrix and matrix A is 2 by 3 matrix. We will see how this affects the dimensions and the result of the product BA. So B is 3 into 2 and A is 2 into 3. Now since column of B is equal to number of rows in A, which is equal to 2, so BA is defined and it is 3 into 3, right? This is because the outer dimension of the matrices determine the size of the product. Okay. Next, we will calculate the product BA. So we multiply the matrix B, which is 2 3 4 5 2 1, by the matrix A, which is 1 minus 2 3 minus 4 2 5, right? So remember, each element in the resulting matrix is the product of the corresponding row from B and column from A. Okay. So which is 2 into 1 plus 3 into minus 4. Next 2 into minus 2 plus 3 into 2. Next 2 into 3 plus 3 into 5, right? Next one is 4 into 1 plus 5 into minus 4. 4 into minus 2 plus 5 into 2. 4 into 3 plus 5 into 5, okay? Next one is 3 into 1 plus 1 into 2 minus 4. 2 into minus 2 plus 1 into 2. And 2 into 3 plus 1 into 5, which is equal to minus 10 to 21, minus 16 to 37, minus 2 and 11, right? Okay. Since AB and BA are of different orders, so here AB is not equal to BA. Even if they were of the same order, their elements could be different, okay? Clear? Hope it's clear to all. Let's move to the next part. NCERT section 3.4.5 example 19. So we have two matrices, matrix A and matrix B. Matrix A is 2 into 2 matrix given by 1 0 0 minus 1. Notice that the diagonal elements are basically 1 and minus 1, which is a characteristic of diagonal matrix. Matrix B is also 2 into 2. Matrix given by matrix B is equal to 0 1 1 0. This is example of some matrix where the rows and columns are swapped actually. Clear? So as we proceed, we will explore operations involving these matrices, okay? So again, you have some times to solve or think about this given question. After that, we will discuss the solution part, okay? So you all can try to attempt. After that, we will discuss the solution part. Okay, so hope you all have attempted the given question. Let us see how can we solve this. So we have two matrices. Matrix A is 2 into 2 matrix with elements 1 0 0 1 minus 1, while matrix B is another 2 into 2 matrix with elements 0 1 1 0. So these matrices will help us to understand the concept of matrix multiplication and its properties, okay? So what will be AB? AB will be 1 0 0 minus 1 into 0 1 1 0, which is equal to, after multiplication, will be equal to 0 1 minus 1 0, right? 0 1 minus 1 0. Notice how each element is calculated by taking the dot by multiplying the corresponding rows of A and column of B. Okay. Now BA will be equal to, what will be BA? BA will be equal to BA will be equal to 0 1 1 0 into 1 0 0 minus 1, which after multiplication we will get 0 minus 1 1 0. Okay, clear? So this clearly, so then it clearly shows that AB not equal to BA, right? It clearly shows that AB not equal to BA, right? AB is basically not equal to BA, isn't it? So let's move to the next example. NCERT section 3.4.5 example 15. Right, NCERT section 3.4.5 example 15. Find AB if matrix A is 0 minus 1 0 2 and matrix B is 3 5 0 0. Clear? So our task is to find the product AB. Right, our task is basically to find product AB. So again, you have some time to solve or think about the given question. After that, we will discuss the solution part. Okay. Okay, so hope you all have tried to attempt the given question. Right. Let us see how can we solve it. So in this example, we are going to find the product of two matrices A and B. matrix A is given by 0, -1, 0, 2, and matrix B is given by 3, 5, 0, 0, right? Clear? So we have AB is equal to 0, -1, 0, 2 into 3, 5, 0, 0, which is equal to 0, 0, 0, 0, right? So you can notice that each element in the resulting matrix is 0. This is called a 0 matrix, okay? Where all elements are 0. So it's important to understand how we arrived at this result by multiplying corresponding elements and summing them up for each position in the resulting matrix, okay? The key takeaway here is that even if the product of two matrices is a 0 matrix, it doesn't necessarily mean that one of the matrices is a 0 matrix, right? So in this example, neither matrix A nor matrix B is 0 matrix, right? Yet their product is 0 matrix, right? This highlights an interesting property of matrix multiplication that can sometimes be counterintuitive, right? So keep this in mind as we explore more properties of matrix. Okay, let's move to the next part. Next is NCERT section 3.4.5 example 16. Okay. So this slide represents an example involving matrix multiplication, right? And the associative property of matrices, right? So the problem requires finding the product A, B, C, A, B into C, and then show that A, B, C is equal to A into B, C. Clear? And matrix A is given as 1, 1, -1, 2, 0, 3, 3, -1, 2. Matrix B is given as 1, 3, 0, 2, -1, 4. And matrix C is given as 2, 1, 2, 3, -4, 2, 0, -2, 1. Okay. So again, you have some time to solve or think about the given question. After that, we will discuss the solution part. Okay. So you all are requested to try to attempt the given question. After that, we will discuss the solution. Okay, so hope you all have attempted the given question. Let us see how can we solve this. Okay, so let's start by calculating the product AB. We have matrix A, which is 3 into 3 matrix, and matrix B, which is 3 into 2 matrix, right? So when multiplying these matrices, we will take each row of A and multiply it by each column of B, right? Summing the products to get each element of the resulting matrix. Okay, so we have AB is equal to matrix AB is equal to matrix A 1, 1, -1, 2, 3, 2, 0, 3, 3, -1, 2 into 1, 3, 0, 2, -1, 4. So after multiplying it, we will get 1 plus 0 plus 1, 3 plus 2 minus 4, 2 plus 0 minus 3, 6 plus 0 plus 12, 3 plus 0 minus 2, 9 minus 2 plus 8, right? Which is equal to 2, 1, -1, 18, 1, 15, okay? So AB into C will be equal to 2, 1, -1, 18, 1, 15 into 1, 2, 3 minus 4, 2, 0, minus 2, 1. Okay. So now let's calculate AB into C. We have already calculated AB as 2, 1, -1, 18, 1, 15 into now, and C is basically 1, 2, 3 minus 4, 2, 0, -2, 1. Clear? So AB into C will be 2, 1, -1, 18, 1, 5, 1, 15 into 1, 2, 3 minus 4, 2, 0, -2, 1. Okay. So AB into C will be equal to 2 plus 2, 4 plus 0, 6 minus 2, -8 plus 1, -1 plus 36, minus 2 plus 0, -3 minus 36, 4 plus 18, 1 plus 30, 2 plus 0, 3 minus 30, minus 4 plus 15. Okay. So AB into C will be equal to 4, 4, 4 minus 7, 35 minus 2 minus 39, 22, 31, 2 minus 27, 11. Okay. Now BC is equal to 1, 3, 0, 2 minus 1, 4 into 1, 2, 3 minus 4, 2, 0 minus 2, 1. Okay. Right. And BC will be equal to B is 3 into 2 matrix and C is 2 into 4 matrix. So when multiplying these matrices, we will get 3 into 4 matrix, right? So BC will be equal to 1, 3, 0, 2 minus 1, 4 into 1, 2, 3 minus 4, 2, 0 minus 2, 1. Okay. So BC will be equal to 1 plus 6, 2 plus 0, 3 minus 6 minus 4 plus 3, 0 plus 4, 0 plus 0, 0 minus 4, 0 plus 2, minus 1 plus 8, minus 2 plus 0, minus 3 minus 8, and 4 plus 4. Okay. So BC will be equal to 7, 2 minus 3 minus 1, 4, 0 minus 4 minus 4, 2, 7 minus 2 minus 1, 8. Okay. Therefore, A into BC will be equal to 1, 1 minus 1, 2, 0, 3, 3 minus 1, 2 into 7, 2 minus 3 minus 1, 4, 0 minus 4, 2, 7 minus 2 minus 11, 8. Okay. Clear? So A into BC will be equal to 1, 1 minus 1, 2, 0, 3, 3 minus 1, 2 into 7, 2 minus 3 minus 1, 4, 0 minus 4, 2, 7 minus 2 minus 11, 8. Okay. So A into BC will be equal to 7 plus 4 minus 7, 2 plus 0 plus 2, minus 3 minus 4 plus 11, minus 1 plus 2 minus 8, right? Next row will be 14 plus 0 plus 21, 4 plus 0 minus 6 plus 0 minus 33, minus 2 plus 0 plus 24. Next row is 21 minus 4 plus 14, 6 plus 0 minus 4, minus 9 plus 4 minus 22, and minus 3 minus 2 plus 16. Okay. So A into BC will be equal to 4, 4, 4 minus 7, 35 minus 2 minus 39, 22, 31, 2 minus 27, 11. Okay. So A into BC is basically equal to 4, 4, 4 minus 7, 35 minus 2 minus 39, 22, 31, 2 minus 27, 11. And AB into C will be equal to 4, 4, 4 minus 7, 35 minus 2 minus 1, 39, 22, 31, 2 minus 27, 11. Okay. Clearly we can see that AB into C is basically equal to A into BC, right? AB into C is basically equal to A into BC. Okay. Right. Okay. So now we will discuss NCERT section 3.4.5 example 17. Okay. So we have three matrices A, B, and C. Matrix A is 3 into 3 matrix with elements arranged as follows. So first row matrix A 0, 6, 7 minus 6, 0, 8, 7 minus 8, 0. Matrix B is 0, 1, 1, 1, 0, 2, 1, 2, 0. Matrix C is 2 minus 2, 3. Now calculate AC, BC and A plus B into C. Also verify that A plus B into C is equal to AC plus BC. Right. So again, you have some time to solve or think about the given question. After that, we will discuss the solution part, right? You all are requested to try to attempt the given question. After that, we will discuss the solution part, right? Okay, so hope you all have hope you all have tried to attempt the given question. Let us see how can we solve it, right? We have three matrices A, B, and C. We have to calculate AC, BC, and A plus B into C. Clear? Now A plus B, what will be A plus B will be 6, 7, 0, 6, 7 minus 6, 0, 8, 7 minus 8, 0 plus 0, 1, 1, 1, 0, 2, 1, 2, 0, which is equal to, after adding these, it will be equal to 0, 7, 8 minus 5, 0, 10, 8 minus 6, 0. So a plus b into c will be equal to 0, 7, 8 minus 5, 0, 10, 8 minus 6, 0 into 2 minus 2, 3. So a plus b into c will be equal to 0 minus 14 plus 24 minus 10 plus 0 plus 30, 16 plus 12 plus 0, which is equal to 10, 20 and 28, right? Which is equal to 10, 20 and 28. So we know that a plus b into c is basically equal to 10, 20 and 28, right? So a plus b into c will be equal to 10, 20 and 28, right? So AC will be equal to 0, 6, 7 minus 6, 0, 8, 7 minus 8, 0 into 2 minus 2, 3. Clear? Right? Clear? Hope it's clear to all till here. Next. So AC will be equal to 0 minus 12 plus 21 minus 12 plus 0 plus 24 and 14 plus 16 plus 0. So matrix AB AC will be 9, 12, 30. Right? Now matrix BC. B is given as B and C are given. So we will multiply these 0, 1, 1, 1, 0, 2, 1, 2, 0, 2 minus 2, 3. Here after multiplication we will get BC is equal to 0 minus 2 plus 3, 2 plus 0 plus 6, 2 minus 4 plus 0. So matrix BC will be equal to 1, 8 minus 2, right? Matrix BC is equal to 1, 8 minus 2. Clear? Now we have matrix AC is 9, 12, 30. Clear? So and BC is 1, 8 minus 2. So AC plus BC will be 9, 12, 30 plus 1, 8 minus 2. And after adding these, we will get 10, 20, 28. And A plus B into C is basically 10, 20, 28, right? A plus B into C is basically 10, 20, 28. Clearly, we can see A plus B into C is basically will be equal to AC plus BC, right? A plus B into C will be equal to AC plus BC, right? Clear? Okay. So hope it's clear to all. Next, NCERT section 3.4.5 example 18. Clear? NCERT section 3.4.5 example 18. So example 18 says if matrix A is 1, 2, 3, 3 minus 2, 1, 4, 2, 1, then show that A to the power 3 minus 23A minus 40I is equal to O. है ना? Right? So our goal is to show that A cube minus 23A minus 40I is equal to O, where I is the identity matrix and O is basically the zero matrix, right? So this example will help us to understand how matrix operations can be used to very specific algebraic identities, right? So again, you have some time to solve or think about the given question. After that, we will discuss the solution part. So you all are requested to try to attempt the given question. After that, we will discuss the solution part. Okay. Okay. So hope you all have tried to attempt the given question. Let us see how can we solve this. We have matrix A as 1, 2, 3, 3 minus 2, 1, 4, 2, 1. And we have to show that A cube minus 23A minus 40I is equal to O. So we have A square. Clear? Matrix A is 1, 2, 3, 3 minus 2, 1, 4, 2, 1. So if we calculate A square, it will be A into A, right? A square will be A into A. Okay. Right. A square will be A into A. Clear? So A square will be 1 into 2 into 3, 1, 2, 3, 3 minus 2, 1, 4, 2, 1 into 1 2 3, 3 minus 2 1, 4 2 1, and after multiplication it will be a square will be equal to 19 4 8 1 12 8 and 14 6 15. Okay, right. So now a cube is basically a into a square, right? A cube is basically a into a square, which is equal to 1 2 3, 3 minus 2 1, 4 2 1, right, into 19 4 8 1 12 8 14 6 15. Okay, clear. So hope it's clear to all till here. So a cube will be 63 46 69, 69 minus 6 23, and 92 46 63, right? Now a cube minus 23a minus 40i will be equal to 63 46 69, 69 minus 6 23, 92 46 63 minus 23 times 1 2 3, 3 minus 2 1 and 4 2 1 minus 40 times 1 0 0 0 1 0 and 0 0 1. Okay, so it will be equal to 63 46 69, 69 minus 6 23, 92 46 63 minus 23 times 1 2 3, 3 minus 2 1 and 4 2 1 1 minus 40 times 1 0 0 0 1 0 and 0 0 1. Okay, so it will be equal to 63 46 69, 69 minus 6 23, 92 46 63 plus minus 23 minus 46 minus 69 minus 69 46 minus 23 minus 92 minus 46 minus 23 plus minus 40 0 0 0 minus 40 0 and 0 0 minus 40. Okay, clear. Hope it's clear to all. Yeah, till here. So now a cube minus 23a minus 40i will be equal to 16 63 minus 23 minus 40, 46 minus 46 plus 0, 69 minus 69 plus 0. Next row 69 minus 69 plus 0, minus 6 plus 46 minus 40, 23 minus 23 plus 0. Next row is 92 minus 92 plus 0, 46 minus 46 plus 0, and 63 minus 23 minus 40. Okay, so aq minus 23a minus 40i will be equal to null matrix 0 0 matrix. Okay, which is equal to O. All elements will be equal to 0. Clear. Therefore, to summarize, we have shown that a cube minus 23a minus 40i is equal to O, right? So this demonstrates how matrix operations can be used to verify matrix equations, right? So it's important to carefully perform each step to ensure accuracy in our calculation. Okay, so let's move to the next part. Next part is NCERT section 3.4.5 example 19. This example says in a legislative assembly election, a political group hired a public relation firm to promote its candidate in three ways, right? Telephone, house calls, and letters. So the cost per contact is given in matrix A. Clear. Cost per contact, telephone, house, letter. The number of contacts of each type made in two cities X and Y is given by matrix B, which is equal to 1000, 500, 5000, 3000, 1000, and 10,000 corresponding to X and Y. Clear. So find the total amount spent by the group in the two cities X and Y. Clear. So again, you have some time to solve or think about the given question. After that, we will discuss the solution part, right? You all are requested to try to attempt the given question. After that, we will discuss the solution part. Okay, so hope you all have tried to attempt the given question. Let us see how can we solve this. Okay, so we have the given question. We have to solve this, we need to multiply the matrices B and A, isn't it? This multiplication will give us total cost for each city. So remember, matrix multiplication involves taking dot product of rows from the first matrix and the column from the second matrix. Okay, so BA will be equal to 1000, 500, 5000, 3000, 1000, 10,000 into 40, 100, 50. After multiplication, we will get BA is equal to 40,000 plus 50,000 plus 2,50,000. Next row is 1,20,000 plus 1 lakh plus 5 lakh is equal to 3,40,000 after addition and 7,20,000 after addition, corresponding to X and Y. Okay, clear? So the total amount spent by the group in the two cities is basically 3,40,000 paise and 7,20,000 paise. That is Rs 3,400 and Rs 7,200. Okay, so this is basically the final answer. Okay, so hope it's clear to all. Thank you so much.